All right, section 1.3, use midpoint and distance formula. This will be the day one notes of 1.3. So the first one, midpoint, the point that divides the segment into two congruent segments. So if we have a segment, and I name it AB, we're talking about the point that divides the segment into two congruent segments. Remember, those little tick marks mean congruent. So we'll call this point M, our midpoint is M, and then we could say, let's go ahead and write that out to midpoint. And we're able to say AM is congruent to MB. AM congruent to MB. All right, the segment bisector. So this is a little bit different. It is the point, ray, line segment, or plane that intersects a segment at its midpoint. So if we have our segment, whatever is intersecting at the midpoint is a bisector. So the midpoint is not the bisector unless it's the point itself. It can be the bisector too. But specifically a line, a ray, a line segment, a plane, anything that is dividing that segment into two equal parts is the bisector. And then your midpoint formula, if we have points A and points B that are points in the coordinate plane, so think of your XY axis, that's the coordinate plane. So A is represented as x1, y1, your x value and your y value. And then B is your second x value and your second y value. So we can do this midpoint formula, which is add our x's together and divide by 2 to find our x of the midpoint. And then add our y's together and divide by 2 to find the y of the midpoint. So x1 plus x2 divided by 2, y1 plus y2 divided by 2. So first example, we need to find RS. RS is this entire segment. We see that the smaller segments are both congruent. We know RT is 21.7. So that tells us that TS is also 21.7. And if we need to find RS, which is that long segment, we just add those two smaller ones together. 21.7 plus 21.7, and that gives us 43.4. So RS is 43.4. And find AB. So go ahead and pause. You guys do this one on your own and then unpause for the answer. All right, done just the same as the one before. Hopefully you got segment AB equals 4 1/2. Remember those two smaller segments are congruent. So CB is also 2 1/4. Just add those together. Next, point C is the midpoint of segment BD. And we need to find the length of BC. BC being this smaller segment here. But since C is the midpoint, we know BC is congruent to CD. So we could set both of those up equal to each other. So 3x minus 2 equals 2x plus 3. And then solve for x and plug x back in. So if we solve for x, I'll add 2 to both sides here. That'll give me 5. And subtract 2x on both sides. That'll give me x. So x equals 5. So x equals 5. We need to take that 5 and plug it back in for x. So 3 times 5 minus 2. So 15 minus 2 is 13. That's BC. Segment BC equals 13. Number 4, D is the midpoint of segment EF. So first, let's draw that out, see what it looks like. We know F is an endpoint, E is an endpoint from EF. That's the segment we're working with. D is the midpoint. And if D is the midpoint, we know ED is congruent to DF. And we'll put those little tick marks. We know ED is 4x plus 6. We know DF is 7x minus 9. And we need to find ED, DF, and EF. So the two smaller segments and the big segment. So first we need to solve for x. So we'll say 4x plus 6 equals 7x minus 9. We know those are two congruent segments. So they're equal to one another. We'll add 9 on both sides. Subtract 4x on both sides. Trying to get x by itself, combining our like terms. So 15 equals 3x. Divide by 3 on both sides. And x equals 5. Okay, so we need to take 5, plug it back in to solve, figure out both ED and DF. So with ED, we would say 4 times 5 plus 6. That's 20 plus 6, 26. And then DF, 7 times 5 minus 9. 7 times 5 is 35. 35 minus 9, 26. And that makes sense. We know that they're congruent. They should be the same. So then to find EF, we just add those two together. 26 plus 26. And that gives us 52. Number 5. LH bisects JK at M. So we see LH. We know that bisects JK, so these smaller segments on JK are going to be congruent, and they bisect there at M. So GM is 2x plus 6. And we know GK, that's that longer segment, both of them together, is 24. So there's a couple of ways we can set this up. We know we have 2x plus 6 is one of the small segments. The other small segment is going to be the same, so it's also 2x plus 6. And we know that will add up to give us 24. So we can combine our like terms. 2x plus 2x, that gives us 4x. 6 and 6 will give us 12. That's equal to 24. Subtract 12. Gives us 4x equals 12, and divide by 4 on both sides for x equals 3. Now, if you recognize right off the bat that 2x plus 6 needs to be half of 24, and you already recognize that 2x plus 6 then equals 12, you could set it up like that and have 2x plus 6 equals 12 and solve for x that way. You will still get x equals 3. All right, number 6, we are finding the coordinates of the midpoint of the segment with the given endpoint. So these are endpoints. Negative 2, 4, and 3, 1 are endpoints of our segment, and we want to find the midpoint. So we need to use the midpoint formula. So we're going to add our two x's together and divide by 2. And then we will add our two y's together, 4 and 1, and divide by 2. So negative 2 plus 3 gives us positive 1. Divide by 2, that just stays 1/2. And then 4 plus 1 is 5 divided by 2. That can stay as 5 halves. So the midpoint of number 6 is 1/2 and 5 halves. So go ahead and pause there and find number 7. All right, so for 7, you should have gotten -4 for x and 9/2 for y. Remember, adding your x's dividing by 2, adding your y's dividing by 2. Moving right along, go ahead and pause here and solve 8 and 9, and then unpause for the answers. All right, hopefully for number 8, you got 5 and 5. Remember, 10/2 simplifies down to 5. It's just 10 divided by 2. And then for number 9, you should have gotten 9/2 for x and -1 for y. Okay, so use the given endpoint R and midpoint M of RS, so they're points on a longer segment of RS, to find the coordinates of the other endpoint, that other endpoint being S. So we're looking for S. So we have R here. I'll write that out as 3, 2, and we know M is 1, 0. I'm looking for the difference, the distance between these values in our x's and our y's to know how much I need to change to find S. So if I go from 3 to 1, think about moving across a number line. I am subtracting 2. I have to subtract 2 from 3 to get 1. So it's a difference of 2 going down. And then from 2 to 0, I would be subtracting 2 to get to 0. So I want to do that same thing to find our other endpoint. So from 1, I need to subtract 2, and that gives me -1. And then from 0, I need to subtract 2, and that gives me -2. So -1, -2 is S, or point S. All right, I'll do 11 with you, and then you guys will do 12 and 13 on your own. So same that we did before, we're starting with R. We know that's one of our endpoints, so we have R at -3, -5, and we're going to be going to M, which is at 2, -6. So to get from -3 to 2, what do we have to do? We have to add 5. So it's not always subtraction. Sometimes we're going up on the number line or to the right on the number line, positive in the number line. But we can also be going -2. So to get from -5 to -6, what are we doing? We're subtracting 1. So to find S, we need to add 5 to the x. We need to add 5 to our midpoint of 2, which will give us 7. And then we need to subtract 1 from -6. And that'll be -7. So that is point S. 7, -7. So go ahead and pause there, do 12 and 13, and then unpause for those answers. So for 12, you should have gotten that the endpoint S was -7, 15. And for 13, hopefully you got the endpoint of S as -13, -3. And notice on them that just because you are subtracting on the X doesn't mean you're not adding on the Y and vice versa. It could be either way. So those are the 1.3 Day 1 notes. Have a great day.